All right, so here we go. We're going to get close to finishing up 1.1 and 1.2. We'll finish up tomorrow. So what's the last thing that you have written in your book?
Extrapolation and interpolation.
Okay, extrapolate and interpolate. Extrapolate, not extra, whatever y'all said. I can't even say that.
Extrapolate.
So, yeah. All right, so extrapolate means to predict outside your data, and interpolate. Means to predict within your data, okay? I'm recording, so who are the recordings for?
Us.
Okay, so they're for you, so don't be distracting in them, all right? So the next thing that we need to talk about is what is general form. Okay, so this is one of the few things in math that I don't really, I don't like the way it happens. But it is what it is, okay? And so we're going to deal with it. You have studied general form before, but you called it something else. I don't like it when people do that, but it's a situational thing, and it's different, authors of different books. And so our book calls this general form. You have studied it and you called it standard form, but they call something else standard form. So why is it important that you know what this book is talking about? Because where did these tests come from?
The book.
That book and that test bank. And so the vocabulary and the verbiage that they're going to be using is what's used in the book. So you need to be aware of that. All right, so general form is in the form of AX plus BY equals C. Okay, tell me what you know about A, B, and C.
C is your slope-intercept. No? It's okay.
A, B, and C must be
Real number. Equal.
integers. Yeah.
Lizzie's so smart.
Okay, integers. That means no fractions and no decimals. That's going to be general form, okay? So no fractions and no decimals. Notice that the X and the Y are both on the left, and the constant or the plain number is on the right. Now, some, not all, but some say that A cannot be negative. Okay, that means that, well, back a long time ago, when I was in school, we were taught that A cannot be negative. That was the stipulation that we were given. A, B, and C must be integers, and A cannot be negative. Now they have removed that, and so I would say if you were in college, you would need to know what your professor thought, right? Because whatever they think, that's what you need to go with.
What do you think?
So I don't really care. It doesn't matter to me. Personally, I'm going to remove the negative because that's the way I was taught when I was growing up. Okay? So, that's the way I do it. But it is not improper to have it as a negative. So
Does it affect anything else?
no, doesn't affect anything else. So this would be like if you had an answer and you got negative 2x plus 3y equals 7, then there are a lot of books now, and they accept that for the answer, okay? I would just divide everything by a negative and write it as 2x minus 3y equals negative 7.
I feel like I remember being told.
Okay? All right. So in the algebra book, it is called standard form, but we're going to call something else standard form, so they call this general form. So I just want you to know that if the directions say put it in general form, this is what they're talking about. So let's try one little example, all right? What if you had 2/3 x is equal to 4 minus 1/2, 4y. I was like, where's my number? 4y minus 1/2. Okay, so the first thing, who's breaking the rules? Yeah, all those fractions up there, okay? So in the fraction, y'all, what's making it a fraction? What part of the fraction is my problem? The denominator is the problem, okay? So he's who I want to work with and make him go away. So if I'm looking at a 3 and a 6, what is the least common multiple of 3 and 6? That's the same thing that your brain does for a least common denominator, okay? Did I say the answer?
Yes.
Sorry.
Thank you.
3 and 2. It is what? 6. Okay, so I'm going to multiply both sides by that least common multiple of these two denominators. And watch what happens. It's going to make the denominators go away. Remember how to multiply this. What does this little line right here mean? Divide. So I'm going to divide by the 3 and multiply by the 2. How many times does 3 go into 6? What is 2 times 2? So that's 4x. Remember doing that? We're going to distribute here. What is 6 times 4y? Aiden?
Couldn't you just put the 6 over 1 and multiply 6 and 2 and 3 and 1?
Yeah.
Yes, but then you get 12 over 3, and what do you have to do?
Simplify.
Reduce it.
What you
Okay?
Yeah, me too.
All right. So over here, how many times does 2 go into 6? What's 3 times 1? All right. Now what's wrong with him?
Not in the right format.
Yeah, they're not in the right place. The x's and the y's should be on the left, and the constant should be on the right. So this 24y, actually what you do, mathematically, you would say, I'm going to subtract 24y from both sides. But my little brain says, hey, pull that 24y over here on the left and do what to him? Change his sign. So he becomes a negative over here. And there is my answer. This is general form. Yes?
Oh, I understand this.
Never mind.
No? Question?
Well, the only thing was like the 4 and the 24. Like, I was just gonna ask if you could like reduce that or not, but
No.
you probably can't.
That's right, you can't.
Is
You
that
cannot
the same
reduce it,
variable?
okay? You cannot reduce it. We're not solving for something or anything like that. We're not factoring or something like that,
Okay.
so that is my equation. All right, anybody got a question? Okay, so let's move on to something else. We're still in section 1. We're getting close to section 2. So the next thing that I want to talk about is parallel and perpendicular. So tell me what parallel lines are. Tell me what's the, first of all, tell me the symbol for parallel.
Double line.
Yeah, it looks like 2 little L's, okay? 2 little L's, that's parallel, all right? And tell me, what am I talking about? Does anybody know the definition of parallel lines?
Their slopes are the same.
That never.
Okay, that's true about them. Their slopes are the same.
Never
They
touch each
never
other.
touch.
They never touch. Okay, so I'm gonna try to do this on the, so it'll be on the video, okay? So look at these 2 lines right here. One's above the other one, okay? One's above the other one. Do these 2 lines right here ever touch?
No.
Are they parallel?
No.
So when you say that definition about 2 lines that never touch, what do they have to be?
They don't intersect.
Equal.
This is parallel. This is what's called skew. Skew, S-K-E-W, skew.
Parabola.
This is parallel. Why are these parallel and these are not? Different what?
No.
Slopes.
Different planes.
Oh.
Parallel lines are coplanar lines that do not intersect. Okay? They have to be coplanar. If you do not say coplanar, then you could be talking about skew lines. They don't intersect either, but they're in 2 totally different planes. Okay? So, yes, parallel lines are coplanar lines that never intersect. All right? And like Jonathan said, yes,
Jonathan's
Brennan,
right.
sorry.
It's not even here. It's not even here.
Sorry, dang it. All right, they have the same, shout out to you, Jonathan. They have the same slope, okay? They have the same slope, all right? Now, what about perpendicular?
I really need a right angle.
Are they?
They make a 90 degree.
Okay, what's the symbol?
The
An upside down capital T, okay? That's perpendicular. And they meet to form a right angle, okay? They do meet to form a right angle, and they are opposite what?
Adjacent.
Very good, reciprocal. What?
I've just heard that somewhere.
Don't repeat everything you hear, remember? It's not a good thing. Opposite reciprocals. So that means you're gonna flip it and change its sign. Do you agree? Okay, so now we're gonna play a game. Love to play games. Have y'all ever played Rummy Cube? If y'all have never played Rummy Cube, y'all thought Pictionary was fun the other day when we played that in the class? Okay, Rummy Cube is tons of fun. You would like Rummy Cube. Do you play Rummy Cube, Sean? I love it, isn't it fun?
Wait, Sean, did you play that at your house? Yeah, I'll play that.
Yeah. Okay, so here we go. We're gonna do this really quick, all right? So I'm gonna give you a slope, and then you're gonna write down what the parallel slope and what the perpendicular slope is.
This is not a fun game.
Okay, are you with me? I'm gonna give you a slope, and then you're gonna write down what the parallel slope and the perpendicular slope is. Okay, so here we go. The first slope I'm gonna give you is 1/2. I want you to write down what is his parallel slope and what is a perpendicular slope.
Oh, that's kinda easy.
All right, are you ready?
Yeah.
What's a parallel slope?
One
One
half.
half.
Ooh, I hope y'all didn't hurt yourselves. What's a perpendicular slope?
Negative
-2. All right, very good. All right, let's do another one. -3. -3. Write down a parallel slope and a perpendicular slope.
Easy goes. Sean's got the same one, though.
Okay, what's a parallel slope? Boys, what's a perpendicular slope?
One half. I mean, one.
Positive 1/3. So flip it and change its sign. Everybody okay? Here's my last one. -3/4. -3/4. What's my parallel slope?
Negative 3/4.
And what's my perpendicular slope?
4/3.
Very good.
1 and 1/3.
All right, no. Okay, so now let's move on. We are going to do example 6. Write this down. Find these in Algebra 2, these are some of the most missed problems on papers, worksheets, and tests. Okay? So it should be good for y'all. That's why I'm like flying through this stuff really fast, because it's just should be kind of like a quick review. So, but pay attention to this one. So find the slope, intercept, form of the line that passes through to -1 and is A, parallel to, and B, perpendicular to. (2x minus 3y equals 5). Okay? Find the slope-intercept form of the line that passes through to -1 and is A, parallel to, and B, perpendicular to 2x minus 3y equals 5. Okay, so here's my first question. How many answers does this problem have?
2.
2. Very good. So it has a line that's going to be parallel, and it has a line that's going to be perpendicular. Are you with me? All right. In order to write an equation, find the slope-intercept form of the line. In order to write an equation for a line, what do I need? 2 things.
You got to have your slope,
Slope,
and then you gotta have
Your point.
a point.
Yeah.
Okay, well, I got a point. So I'm going to need a slope. I need a slope that's parallel to this line, and I need a slope that's perpendicular to this line. So what do I need to find with this line right here? You better find a slope. How am I going to find a slope? What do you do? Yeah, just solve for y, people. Okay, solve for y. So -3y is equal to -2x plus 5. Now what do I do?
Divide by -3.
Divide by -3. They multiplied, so we divide. And so y is equal to, a negative over a negative is a positive 2/3 x. A positive over negative is a negative 5/3. Okay, so what is this guy's slope?
2/3.
2/3. Okay, so watch this. Okay, watch this. This is what I'm going to do. A, my point is 2, -1. They gave that to me in the problem.
And you have to
Okay.
go run.
And my parallel slope is going to be parallel slope. 2/3. Do you see why we played the game? Okay, we're doing the same thing. Y'all are playing the game. All right, parallel slopes are the same, so he's 2/3. B is going to be the same point, 2, -1, but this time I want a perpendicular slope. What is a perpendicular slope to that line?
-3/2.
-3/2. Now, is this exactly like what we did yesterday?
Yes.
Yes. Tell me what I'm going to use. Point slope formula. So y minus y1 equals m times x minus x1. This is my x sub 1 and y sub 1. All I'm going to do is plug them in. So, on the left, I'm going to be left with y minus what? Yeah, minus a negative is going to be a +1. Is equal to, what's m?
2/3.
2/3. Times x minus, what's x sub 1?
2.
2. Distribute and collect. We did this yesterday, guys. We did this yesterday. So we're going to distribute here and here. So I got y plus 1 is equal to 2/3 times x is what?
2/3 x.
2/3 x. 2/3 times this. Y'all, 3 does not divide into 2. So if you need to, you could go over here to the side and do a little chicken scratch. 2/3 times 2/1.
4/3.
Top times top, bottom times bottom. Positive times negative is a negative 4/3. I do not want decimals and I do not want mixed numbers. Okay? Now what do I do? I'm going to subtract this 1. Now y'all look, when I subtract 1 over here, it goes away. When I minus the 1 over here, I'm going to go ahead and find a common denominator. 3/3. That is 1. Okay? So I'm left with y is equal to 2/3 x. These are like signs. What do you be very careful here? This is an easy place to make careless mistakes. What do like signs? What do? You add and take the sign above. So -7/3. So this is my equation. He's parallel. Y is equal to 2/3 x minus 7/3. Okay, so I'm warning you right now. This is what at least 3 kids in here are going to do. They're going to say, oh, I got me an equation, so I'm just going to change his slope and write him down here.
No.
No, that is not right, people. If that were the way you do it, that's the way I would have taught it. Okay? You have to go and do all of this stuff again. You can't just use this equation. Could I check this equation and make sure that he goes through that point?
Yes.
Yeah, it might be a good thing to do. Okay, you can put it in y equals and check it. If it goes through 2, -1, you're like, yeah, slope's the same. I'm good. All right, so let's do that point slope form. Y minus y1 equals m times x minus x1. So this is x sub 1, y sub 1. So that's going to be y minus a -1 is equal to, my slope is -3/2 times x minus 2. So this becomes y plus 1 is equal to, distribute, and then I'll collect. So when I distribute here, I get -3/2 x. What's a negative times a negative?
Positive.
Positive.
3.
Okay? What happens to these 2's, guys?
Cancel.
They cancel. If you don't know that, look what happens. 3/2 times 2/1.
Cross multiply.
3. No, cross
Simplify.
multiply.
That's all.
Cross simplify. Cross reduce, whatever y'all want to call it. Negative times negative is a positive and it's just 3. Now what do I do?
Subtract 1.
Subtract 1. No, y'all listen to me. This is easy math. Alright? Don't make stupid mistakes. Y is equal to -3/2 x plus 2. Anybody got a question? Everybody okay?
Yes, but I lost my notes from yesterday.
You can take a picture of mine if you want to. All right, so here we go. We're gonna start 1.2. 1.2 is all about the function. Okay? All about the function. I think you'll be okay. All right, so, everybody ready? What time's the bell ringing here? 50? Okay, good. All right, so here we go. The first, now look, I'm giving you some vocabulary, because obviously we're gonna be using the vocabulary. So if I'm using it and you don't know what it means, then we got a problem, okay? So the first thing I wanna define is a relation. Okay, a relation. A relation is when pairs of quantities are related to each other by some rule. Related to each other by some rule. Now, it could be like x's and y's and they're related by an equation that someone gave you, okay? And you plug your x in and you solve for your y. Or it could just be something like this. C is equal to 2 pi r. The relationship is between the radius of a circle and his circumference. Is there a relationship between the radius of a circle and a circumference? Yes, there most definitely is. If I want to know the circumference, I can take 2 pi and multiply it by the radius, and it will tell it to me, okay? So this is a relation, all right? This is a relation. Now, there is a very special relation, and he's called a function, okay? A function is just a relation, but it's special. It's a relation in which every x has only, one y. All right? If every x has exactly one y, then that is a function. Okay? Every x has exactly one y.
I found one of those, by the way. They were just like randomly put in here.
Randomly. All right. So, I'm going to go on to the next page. Because I'm going to talk about things and I kind of want them all together in my notes. All right. So, I'm going to tell different ways to represent a function or a relation. Actually, I'm going to show you different ways to represent a relation, and then you're going to tell me, how could I tell really easy if that is a function or not? Okay? So these are ways to represent a relation or a function. Okay? So the first one, a list of points. I could just give you a list of points. I could give it to you like this in a T-chart. Or I could give it to you like this, which is really just a T-chart sideways, but we call it a table.
Oh, I never realized that.
Okay? Or I could give it to you as a set where I just listed a bunch of points. Do you know what I'm talking about? Is everybody okay with that? So there's 3 different ways that I could list my points. They look different, but they're all essentially the same thing. Just a list of points. All right? So how will I tell if a list of points is a function or not? Anybody?
If it's one Y, one X, one Y.
If the x's don't repeat and the
Yeah.
y's,
Yeah.
Yeah.
Y'all look. I can say if every x only has one y, but then I have to go through and make sure every x has only one y, right? But what if I say the x's don't repeat? Isn't that good? Is that fast? Can I look really fast and go, oh, the x's don't repeat, he's a function. The x's don't repeat, he's a function. Here it's a little more difficult because you have to look across a bunch of numbers. That's always a more difficult skill you need to be careful with. So the x's cannot repeat. All right, thank you, Brennan. That was awesome. All right, number 2. I could give it to you as a graph. Do you agree? So then it'll be just on a little coordinate plane. Here's my x-axis and my y-axis. And you might just plot some points there and stuff. Do you see what I'm saying? How, when I'm looking at a graph, will I tell if it is a function or not?
Horizontal line test.
If no points are directly above or below each other.
Okay, so
Pencil test.
yes,
Yeah, the
it
test.
must pass the vertical line test. Okay?
If it passes the vertical line test, that means no x's repeat.
That's exactly right. So what do we use for a vertical line test?
A pencil.
No.
A feather. Quill.
A quill. This is a porcupine quill. This is not a feather.
My fault.
All right. So you get your porcupine quill out, right? You get you a line, a straight line, and then you run it across your graph. If it intersects more than one point at a time, then it is not a function. If it only hits the graph at one place at a time, it is a function. So if I ran it across this guy right here, you can see when it bumps these 2 points right here, it hits them at the same time.
Oh.
Here's what that means. It means that this x has 2 y's, one up here and one down here. That's not a function, okay? Doesn't pass the vertical line test. Not a function. Do you understand?
Normally they'll be bigger where we can actually like tell 100%.
Yeah, I just dotted the paper. It's okay. Okay, I figure y'all know all this stuff. I'm not really concerned with you. All right, now this is the most difficult one to do, and that's if I give you an equation. All right, these other two, they're pretty simple and straightforward, okay? But an equation, you're going to have to think, all right? You're going to have to really think. So you're going to have to use your base of knowledge, okay? So what if I gave you this equation right here? X squared plus y equals 1. Okay? Well, I know if it has an x squared, it looks like a what?
Parabola.
A parabola. When I graph a parabola, is that a function?
Yes, 'cause they don't touch.
Yes.
Yes, it is. It's a parabola, and it either opens up or it opens down.
Let's go.
Okay? So, is that a function? Yes, it is. All right? If you wanted to know specifically what this guy looks like, you would solve for y. Y is equal to negative x squared plus 1. What does that negative make my parabola do?
Open down.
Up, he's opening down, okay? It reflects him over the
X.
x-axis, because he's really on the y, because it actually is like this. Okay, he's outside those parentheses. What about this plus 1? What does that do to it?
Brings it up.
Started
Brings it up 1. So he starts here and he looks like this. And then you can tell if you were going to run the vertical line test on him, okay, that you could run it. Now remember guys, this is a curve. Are there any parts of a curve that are straight?
No.
No, so this thing doesn't like just go straight down like that. He's ever so slightly out to the right and the left. And so you can see that he does pass the vertical line test. All right? Now, what if I gave you this guy right here?
No.
Now, here's what I'm asking you to do.
It's just a
I'm
sideways
asking you to reason. You know what this is and what it does. When I square the x, think about what that does. So what is it going to do when I square the y?
Flip it sideways and then the X's
Yeah.
touch.
So that's just going to be a sideways parabola. He's going to open right or left. Is he a function?
No. Dang, I remember this. Let's go.
Yeah. No, he's not. You notice that if you run the vertical line test on this guy, as soon as you touch that vertex, that's the point of tangency, okay? And that's the only time it will hit that thing one time. The rest of the time, he's bumping it at the top and the bottom every stinking time, okay? I'm going to show you why, okay?
So it's just if the x is squared, it is. If the y is squared, it's not.
That's exactly right. And I'm going to show you why. Hang on just a second. Okay, so this is gonna be why. You don't, I'm gonna solve for this y. Because really when I graph something, that's what you're gonna do. You're gonna solve for the y. So do you agree it looks like this? Y squared is equal to x plus 1. Are you with that? Okay, I'm gonna square root both sides. Oh, no. Anytime you're solving an equation and you take a square root, what do you have to put?
Plus or
A
minus.
plus or a minus. Okay? That's taking in those two x's. One will be positive and one will be negative. So the square root of x plus 1. So there's those two values. This y has two x's. Okay? All right. So here we go. What's the next thing we're doing? Oh, function notation. Oh, I love this one. Watch this. Function notation.
Is this 4?
Huh?
Is this 4 or no? It's just the only thing.
No, it's just something else we're talking about.
Okay.
All right, function notation. Function notation is when I write things like f of x. Do you agree? All right, it's the same as what?
Y.
Yeah, the same as y. F of x is the same as y. Sometimes you'll see g of x, h of x, k of x. You could do anything of x, okay? Anything. You could even do like different variables, like
Could you do P of Q?
p of q. You could do
P of B? Peanut butter and jelly?
your d of t. You could do d of t. That's your distance with respect to time. Do you see what I'm saying? So it could mean something in the equation that you're talking about. All right, so function notation. So this is example 3, all right? I'm going to tell you that g of x is equal to negative x squared plus 4x plus 1. Okay? Negative x squared plus 4x plus 1. So the very first thing that I want you to do is I want you to find g of 2.
Well, wait.
You should be able to do that. I want you to find g of 2. I'm going to give you about a minute. So what are you doing? Plugging it in, people. Plug it in. All right. Anybody get 13 for an answer?
I got 5.
You got 13.
I got 5.
5 is good. 13's bad.
Oh, let's
So,
go!
let me show you. Let me show you what you did. Okay. It is a very common mistake,
It's
and I
not in parentheses.
specifically used this problem to see if you would do it. Okay. So when I plug it in, it looks like this.
It's not in parentheses, guys. You gotta keep the
Okay. So y'all listen to me. This is the opposite of x squared. This is not negative x squared. Okay? So when you do this operation right here, only this 2 is squared. Okay? So what is 2 squared?
4.
And the opposite of 4?
Negative 4.
What's 4 times 2?
8.
Plus 1. 8 and 1 make 9, right? So negative 4 plus 9, and that makes 5. Okay? So G of 2 is 5. What does that mean?
When X is 2, Y is 5.
Very good. When X is 2, Y is 5. It means good. It means that the point 25 is on this parabola. Do you agree? Are you with me?
Yes.
Okay, pay attention. All right? Y'all listen to me. It is not this. If you wanna know if kids know what they're doing, you put a test, y'all listen to me. If I'd have put a negative 2x squared right there, you would have all gotten it right. But when I take the that number coefficient, but except a 1, and I just pop that negative out there, then I'm gonna find out who knows what they're doing and who's gonna get sucked into something stupid. All right? This is totally different. This is what you got if you did 13. You said that's 4 plus 8 plus 1, and there's the 13. But that is not right. Bailey.
So, if they give us that question, and will they give us the parentheses if?
Will they ask you to find G of 2? Yeah. They're gonna give you this right here, and they're gonna say, hey, find G of 2 for me.
But then put the negative B on the inside, like.
Only if it were given to you in parentheses.
Like parentheses, negative x,
Parentheses,
parentheses
yes.
squared.
Just
So
like,
you cannot put the parentheses there.
you can't put your own parentheses. No, you may not.
Okay.
All right, here you go. Here's your next one. Are you ready? B. Find me G of T. You have 30 seconds.
G of T?
Find me G of T.
You're gonna wanna.
I don't know, what's the question?
Yo, with Kelly right
No number there.
Find me G. Yeah,
Oh,
that's why I said you have 30 seconds.
of the
People,
same
if it takes you
equation,
longer than 30 seconds to plug a T in for an X,
but it's the same equation.
shame on you. So it is what? Negative T squared plus 4T plus 1.
Well, see, my T's look like plus signs, so it
Yeah,
looks
me
like
too.
negative plus squared
That
plus
sounds like a
4 plus
penmanship
T.
problem to me. Okay, here's C. Like put a little tail on the end of them.
Looks like negative plus square.
All right, I want you to find me G of X plus 2. Uh-oh. G of X plus 2. Remember where that negative sign goes. That's the way it should have started out. And let me warn you right here,
Oil.
that is not X squared plus 4.
No, it's x squared plus 4 plus, no, plus 4x
Yes,
plus 4.
okay. So, remember that, it's negative, and then remember how to square a binomial, okay? How do you square a binomial? Okay, let's write it down. Square the first. What else?
Keep the sign.
Keep the sign. Number 3, what? Twice their product. And number 4, plus square the last. So if you learn how to do it like this really, really fast, then it's a lot easier. So square the first and tell me what you get.
X squared,
Keep the sign. It's that sign right there.
yeah,
If it's a plus, you write a plus. If it's a minus, you write a minus. Twice their product.
4x.
Their product is what you get when you multiply the first and the last. That's 2x. Twice that is what?
4x.
4x. Plus square the last. 4. And then plus, I'm going to go ahead and distribute here. I'm running out of room. 4x plus 8
Plus 1.
plus 1. Okay? All right. So now I'm going to distribute this negative. He'll just change all these signs. So negative x squared minus 4x minus 4 plus 4x, and then 8 and 1 make 9. Okay? Now, who do I start with, guys?
Negative x squared.
Yeah, you always start with your highest exponent. So this guy goes first. Negative x squared. I like to cross them out as I go so then I don't look at them anymore. Okay? What's a negative 4x and a positive 4x?
Nothing.
Bam! You're gone. What's a negative 4 and a positive 9? And there's my answer. Anybody got a question?
Is this what the test gonna be like?
But hopefully,
Yeah, it is.
Is that what it is?
This is what you're working worksheet's like. Are y'all feeling okay?
I'm so excited, Miss Davis, you don't understand.
All right.
This last, Miss Davis, this last test probably dropped me down really far.
I just
This
dropped
next
down
test
further.
gonna bump me up.
Okay, so we got about 7 minutes, so let's see how far we can get. Domain, the other class is a little ahead of you. Domain of a function. All right, now listen to me. You better pay attention on this part right here, because this is the part that you messed up on in Algebra 2. This is very difficult skill in Algebra 2. That means that this year it should be better. Do you agree?
No.
I just
The second time you learn something, it's always easier, guys. Okay? So, domain of a function. Here's what we're going to do. We're going to write the domain in proper set notation. Proper set. Remember, this is what proper set looks like. It opens with a brace. It says any x such that, that's just a
Oh, I
line.
hated this.
You could put a colon,
Such that.
all right? And then it'll tell you what the domain is, and then it'll close it off. Okay? We are also going to write it in interval notation. Remember that interval notation has the parentheses or the brackets. It has infinities, things like that. Okay? We need to be careful. Because your domain could be implied. Heavy on the word lied right there. All right? It could be implied. What does implied mean?
Already given. Oh, it's like already in the equation. It's in it. It's live. It's lying. Ain't even there. It's
No.
false.
If I'm in,
Ghost.
oh, it's understood. Is it said straight out?
No, but if
No, I could be implying something, okay? Maybe I'm implying that you cheated,
but it may
but
be
I
a
didn't
lie.
say that you did, okay? So it's implied. Is it gonna be straightforward and in your face? No, you're gonna have to be thinking. So let's look at an example. For example, okay? C equals 2 pi r. First of all, who is my domain? There are only two variables up there, C and R. Who is my domain?
C.
R.
I was 50-50.
R. Okay? This is my domain. This is my independent variable. He's who I would plug in. He determines my circumference. The size of the radius determines your, this is independent, this is dependent.
Oh.
The circumference depends on what the length of the radius is. Okay? So, what's the domain? All real numbers? So any R such that? All real numbers? So tell me what a circle looks like that has a radius of -2.
Doesn't. Can't.
Oh, so maybe it's not all real numbers.
It's all positive numbers.
All positive numbers. Could it be 0?
No.
You don't really have a circle with 0, but some kids like to include the 0. I'm not going to argue with you. I don't care if you do or not. I'm not going to. So I say R is greater than 0. That's my domain.
You darn right it is.
That is implied, people, because you said all real numbers, and I said, oh,
No,
no,
it
no,
can't
no.
have negatives.
Can't have negatives, okay? In interval notation, what will this look like? Where does it start?
Brackets. I mean, wait. Which one's
Parentheses.
That's
0,
Is that-
not included, okay? 0 is not included, that's a parentheses. All the way to positive infinity, which is never included.
Wait, so my question, is that not called a bracket? Is a parenthesis not a bracket?
No, a bracket is a square one like this right here.
That's my
This is
fault.
a parentheses, this is a brace. All right, write one more thing down and then we'll stop. Okay, we'll be just a little bit behind. So, domain restrictions. Domain restrictions. So here's the deal, guys. Before now, every time I say domain, you thought what?
X.
X. Now, when I say domain, I want you to think restrictions. Are there any restrictions? People, there are only two. The first one is if you have an X in the denominator. Why is that a restriction? What cannot be in the denominator of a fraction?
X.
A variable.
No, I can have a variable in the denominator. It makes a rational function.
Oh,
What's undefined?
0.
Zero. Division by zero is undefined. If you get a zero in the denominator, that's going to be a problem.
I so
Okay.
yes.
All right. So I'm going to stop right there, and we will start here tomorrow. Okay? We will start here tomorrow.
Brennan.
Wait, you know when you. Okay.
Stop on